In this lesson, we're going to look at some composite functions and inverse functions. So we've learned about functions, we've studied some different types of functions, and now we want to talk about what it means to put these functions together. That's what we call a composition, all right? So let's start off investigating some functions here. And we have some function notation. So we want to find f of 5. Remember how to do that? Remember, this is in the same spot as that x is right there. So everywhere we have an x, we need to put 5. So we got 5 squared. Should put parentheses around it. Plus 3 times 5. And that's 25 plus 15, which is 40. All right? So not a problem when we got a positive number. Just plug it in. Same thing when we got a negative number. All right? 3 times negative 5. And that's going to be 25 minus 15 now. And that's going to be 10. Well, what if we want to plug in 3a? Well, now we got to be a little more careful. But we're going to do the same thing. Remember, a just represents a number. So we're going to take that. That's our x value. So when looking at our function, we have x squared plus 3x. So we have, I'm going to write as blank squared plus 3 times some blank. And what goes in the blank? Well, 3a does. And there we have our expression. Now it's just a matter of simplifying. When we square, remember we square both of these here because they're in parentheses. Got to write that in parentheses. If you don't write that in parentheses to start with, you're going to have trouble. Now, this is not distribution because there's no plus in there. So it's 3 times 3a. So 3 times 3 is 9 times 8. Okay? So there is f of 3a. So we can plug in positive numbers. We can plug in negative numbers. We can plug in variable numbers like 3a. All right? And how about if we plug in a plus 3 or 3 plus a? We can do the same thing. This one has a plus, so it's going to get a little more complex here. All right, so we have 3. That 3 comes from the original problem. And we have 3 plus a. Okay, and so to work this out here, we're going to square. And then we're going to distribute this guy here, 9 plus 3a. Let's combine some like terms. We got a squared there. We've got a 6a plus a 3a. And we got a 9 plus a 9. That is 18. And so that is our simplified equation there. Okay, expression. So now we can substitute all different kinds of things. So let's talk about composite functions, all right? So to start off, we got a little example, a little situation here that's going to kind of show us what a composite function is all about, all right? So here's our situation. I've decided that I'm going to go in the coffee business, all right? Enough math teaching. Gonna go make some coffees. And I'm going to call it simply lattes because, you know, everyone likes lattes, you know. I'm going to charge $2.50 per latte, all right? And my overhead is going to be $175 per day. That's my rent, my heat, whatever, my expenses just to keep the thing going. And I figured out that each cup of coffee is going to cost me 75 cents to make. So from this situation, we got these equations here. We know that our revenue, how much money we bring in, well, that depends on the cups of coffee in. So I got 250, 2.5 times n, because I'm selling them $2.50 a piece, okay? And then the cost, well, the cost is $175 straight up, and then I got to add in 75 cents for every cup of coffee, every latte that I sell here, all right? So n is the number of lattes that we're going to sell. Now, after being open for several months, I've discovered that the number of lattes sold is a function of the high temperature. So if it gets hotter, then I don't sell as many because all I make is hot stuff. None of this cold frou-frou stuff, you know. And if it gets cold, well, I sell more because everyone wants a nice hot latte, all right? So that's the idea. So I got this little function here. And so it says the number of lattes that I sell as a function of the temperature is 240 minus 2T. All right? And so let's just assume or pretend that this is what I got after months and months of studying the data and what happened. So from this, we can make a new function for revenue and cost in terms of T. So if we look back at our revenue function here, I know that for every every latte I sell here, I get 250. Well, how many lattes am I going to sell? Well, I'm going to sell this many. I'm going to sell 240 minus 2T. That's how many I'm going to sell, and that's in. If I multiply that by 2.5, now I can figure out what my revenue is. And so this now is a function of T. All right? So you tell me T, and I'll tell you the revenue. Let's go ahead and clean that up a little bit. If we distribute here, we get R of T equals 2.5 times 240, 600, and then 2.5 times 2 is going to be 5T. All right. The cost, well, we got our cost function here as a function of N. And so the cost is going to be 0.75 times N plus 175. Well, what is N? What determines N? We just found out that the temperature determines N. So we're going to go ahead and substitute that for N. So let's put the temperature in here, all right? And so how we figure out N, this is 0.75 times N, is 240 minus 2T, all right? And so if I distribute this here, 0.75 times 240 is 180, and it's going to be 1.5T, all right? And so here's our cost function, a new function that once you know the temperature, we'll figure out how much this costs. Let's clean this up here. This is 355 minus 1.5T. Okay, all right. So now we have cost as a function of the temperature. Last but not least, we want the profit. Well, profit is just revenue minus cost. So let's go ahead and take our revenue here, and we're going to subtract the cost from it. Okay, actually that's not the cost. This guy in the box. Okay, so profit is revenue minus cost. So let's make an equation for that there. We've got P of T is the revenue. What's our revenue? 600 minus 5T. So we got 600 minus 5T. And we have the cost of 355 minus 1.5T. So minus 355 minus 1.5T. Okay? So this is subtraction, so we got to distribute this negative out. It goes to both. We can just combine like terms. 600 minus 355, that's going to give us 245. And we've got negative 5T minus negative, which becomes a plus. So this is going to be minus 3.5T. Okay? And finally, there is our P of T. Okay? So what this does for us, not sure what that little stray thing is there. What this does for us is this gives us a way so that when you know the temperature, you can just plug it in and you get the profit, all right? Assuming that all my calculations are perfect, assuming that the function I actually started with is actually a true function, all right? So that's the idea, all right? So let's look at some more composites. So what we just did is called a composition of functions. We took one function and put it inside of another, all right? And we get a new function that can be useful in different ways, all right? So now let's find some compositions. Oh, we write this notation here. We write it as this. This means f of g. or the composition of function f with g. So f composed with g. And it's useful to write it this way, which is f of g of x, because we can see that g is getting put into f, all right? And so we got to watch out for the domain. We'll see about that in a bit here. All right, so let's try a little example. We've got two functions. We've got f here, and we have g of x. All right, and we want to do some compositions. So to do this here, we've got, let's start with what we have. We have f of g, or f composed with g of 2. Again, it helps a lot to write this out as f of g of, not x, but 2. F of g of 2. Okay? So this means we need to find out what g of 2 is, and whatever that g of 2 is going to be equal to some number. And we're going to take that number, and we're going to put that inside of f. And then we'll find our second mystery number, all right? So let's do that. So we have g of 2 is 2 squared plus 4, which is 4 plus 4, which is 8. So f of g of 2 is going to be 2 times x, but x is what we got from f. So we're going to plug in 8 minus 5. All right, and now we can just compute that. 2 times 8 is 16, minus 5, that's 11. Okay, that's how we do a composition there. Now that's a composition with a number. We'll do one with a variable in a minute. So now let's switch it up here. We have a g composed with f. So that means that we want g, and inside of g we want f of x. And we're going to be a little more specific with this one. We actually know what x is, and in this case, we know that x is 2. So we're going to put 2 inside of f. So that means we've got to figure out f of 2 first. Let's go figure out what f of 2 is. F of 2, using our f function here, we have 2 times 2 minus 5. And that's going to be 4 minus 5, which is negative 1. So that can go inside of g. So g is negative 1, so this means g of negative 1. So we want to figure out what g is when x is negative 1. So let's plug it into here. And so we get negative 1 squared plus 4. Okay? And so that's just 1 plus 4, which is 5. There's our final answer. All right, now let's generalize this here. So now that was plugging in a specific value. Now we're going to plug in x. So this is f composed with g of x. All right. So what we're going to do now is we're going to take f, and we're going to put inside of f, we're going to put g of x. All right. So let's do that. Now look at our function here. F is 2 times x minus 5. So we're going to write that as 2 times x minus 5. Now I'm just going to leave this as some empty parentheses. Notice this is 2x minus 5, okay? 2x minus 5. And we're going to put something inside of that x spot. X is just kind of a placeholder, right? And so what we need to put inside of there is g of x. Well, what is g of x? It's x squared plus 4. So now we have an expression here that we can simplify, and we'll get a new equation or a new expression. And so that becomes, when we distribute here, distribute our 2, we get 2x squared plus 8. And we got the minus 5 that we had. And now we can clean that up, and we get 2x squared plus 3. And so that is f of g of x, or f composed with g. So that's the idea. Let's try g of f of x. If you want to pause it, it's a good place to pause it and try it out for yourself. See if you can figure this out here. We're going to put f inside of g. So g is the outside function, and we'll put f of x inside. And so we go look at g here. G is x squared plus 4. So it's x squared, but I'm going to write that just as blank squared plus 4. What goes in that blank? Well, we want to put f of x in that blank. And f of x is 2x minus 5. Okay? So now it's just a matter of cleaning this up. We'd like to simplify it here. Technically, we've got our answer there. A lot of times we just want to leave it that way. But if we go ahead and simplify it, that'd be kind of nice. We can square this binomial. Remember how to do that? We square the first thing, 4x squared. We're going to square the second part. That'll be plus 25. And then we have 2 times the product. And we multiply these things, we get negative 10, doubled 20. And then bring down the plus 4. And we can clean it up. We get 4x squared minus 20x plus 29. And that's g of f of x, also known as g composed with f. So again, the idea is we have 2 functions, and we can put them together. We can use one function to evaluate the other there. All right? And that's all a composition is. So here, let's look at a little different way to look at it. How about a table? So here's a table that gives us a bunch of values. For these x's, if you plug this f of negative 4 into here, you get negative 6. If you plug negative 4 into g, you get 15. All right? So let's go ahead and find what g of f of negative 3 is. So g of f of negative 3. G composed with f. So we're going to figure out what f of negative 3 is first. Well, f of negative 3 is negative 4. So we can rewrite this as g of negative 4. All right. And so when we plug negative 4 into g, what is g when f is negative 4, x is negative 4? So when we put negative 4 into g, we get 15. So our final answer is 15. Okay. Now let's compose the other way. So f of g of x, or in this case, g of negative 3. Let's see what that's worth. Well, here we're going to work from the inside out. G of negative 3, so when we plug negative 3 into g, we get 10. So this gives us, now we're looking for f of 10. Well, now we're going to look in our table here and we'll find out when x is 10, what is f? Uh-oh, there is no 10. Maybe that's a typo. Well, no, not really. So what we're saying here is that f is not defined when x is 10. And this is all the information we have here in this table. That's what we have. So we have to say that this is undefined. There is no definition. All right? So the reason is that this is undefined is g of negative 3 is not in the domain of f. So the output of g is not in f. And that's where we saw on the previous page in the definition there, where we want, actually up above here, we said here that x is in the domain of g and g of x is in the domain of f, because what comes out of g has to be able to be evaluated in f. Otherwise, it doesn't work. And that's what happens down here. What came out of g of negative 3 was not a legal input in f because we don't know what it is. All right, that's a composition. Now that we understand what a composition is, we can talk about inverses. All right? So let's go back to our Simply Latte company here that I'm working hard on starting here. And I'm not getting very far. So I've decided to sell some merchandise at my Simply Lattes. Got to have some merchandise. So I'm going to mark everything up 50% of what I buy it for. This gives me the following function. So my cost for my sales price, I'll call it M of X for my merchandise, is equal to 1.5 times X. All right, so I'm going to sell it for 1.5 as much as I buy it for. All right, X is the wholesale price. Let's think of it that way. All right, so to boost my sales, I'm going to go ahead and have a big discount to get things rolling here, and I'm going to sell my merchandise for 2/3 of the regular price. So this gives me the following function. My sale price is 2/3 of what X is, where X here is the price I was selling it for. All right? So let's do some computations here and see what happens under this little arrangement here. So let's say I buy something for $4. All right, maybe some stickers or some mugs or something like that. All right, got a little mug for $4. I'm going to sell it. The regular price, M of X, that's M of 4. That's 1.5 times 4. That's 6. Now, if I take that price, that regular price, and I'm going to figure out my sales price. So let's figure out what S of 6 is. So I'm putting 6 into my sale function because I got to figure out what the sale price is. So the sale price is 2/3 of 6, and 2/3 times 6 is, well, that's 12/3. Oh, that is 4. Oh, kind of interesting. So the sale price became what the wholesale price was there. All right. So what if we have 12? All right, I'm gonna sell some shirts. All right, I buy some shirts for $12. Got to figure out what I'm gonna sell them for. So my price here is 1.5 times 12. 1.5 times 12 is $18. 1.5 times 12. And so now, got to figure out what my sale price is. So normally I sell it for 18, but on my big 2/3 sale, 2/3 times 18 is, well, 2/3 times 18, divide this by 3 times 2, we're going to get 12. All right. And last but not least, for $7, they're going to buy some hats. These hats are going to be $7. Got to figure out how much I'm going to sell them for. So M of 7, that's 1.5 times 7. That's going to be 10.5. And so my sale price, I'm going to take that 10.5, and I want to figure out what 2/3 of 10.5 is. All right. And if I, let's see, if I double 2 times 10.5 is 21, divided by 3 is 7. Huh, that's kind of odd. So here I got two functions. I got 1.5x and I've got 2/3 x. And when I do one function after the other, well, I get what I started with. Started with 4, ended up with 4. Started with 12, ended up with 12. Started with 7, ended up with 7. So I'm doing a lot of work for nothing here. And so basically my sale is just selling everything for the price I bought it for. So that'd be kind of nice to know rather than trying to go through and figure out the sale price for all my merchandise that I have. And it's just going to come out to be the same. So let's see why that is. Let's compose these two functions here and let's just keep it generic. So in terms of X, let's see what's going on. So I have my sale price, so S of M of X. Let's compose the functions that way. S was 2/3 of whatever the price was. And so our price, M of X, was 1.5x. So when we simplify this here, we have 2/3 of 1.5 is just 1x. Okay, don't necessarily need the 1 there, so We just have x. Oh. So that means if we put x into m and then put whatever comes out of there into s, I just get x. So after going through all that work, because I started with x, I end with x. Interesting. So if we switch it around here, we have m. Well, m was 1.5 times s of x, and we look up above at what the function was, s of x. S of x is just 2/3 x. All right, so now 1.5 times 2/3. Well, 1.5 times 2 is 3. All divided by 3 is just 1. So this again is 1x. Don't need the 1 there. It's just x. So again, if we were to do it the other way around, if I would compute the sale price, plug in s, do the s function first, and then plug that into m, well, again, I would still end up with m. So we have a special relationship. Here these functions are undoing each other. So since they're undoing each other, we call them inverse functions. They're just doing opposites. That's why one thing kind of bumps the price up. The other one just takes the price right back down. They're inverse functions. And the definition of an inverse function is two functions, f and g. They're inverse functions if f composed of g of x gives us x, okay, for all x in the domain of g, and g of f of x gives us x. In other words, if you work out one function and then plug that into this next function, you're just going to get the same number you started with. They undo each other. All right. So in this case, we can say that the function g is the inverse of the function f of x. All right. And we're going to write that like this. G is the inverse of f. All right. So this little -1 is going to be our notation for an inverse, all right? Let's keep rolling. Let's look at a few examples here. We'll do some compositions here. We want to verify that these are inverse functions, all right? To verify, we have to compose f with g and then do it the other way around. So here we go. Let's say we have f of g of x. All right, let's compose that. Well, f says we have 2 times blank plus 3. Again, this is just a good, safe way to do this. Otherwise, you'll get really confused. Look at the form of this. This is just 2x plus 3. And in this case, our x is g of x. So we're going to plug g of x in for the blank here. So x minus 3 over 2. Now we're going to clean this up. These 2's are going to cancel. And that leaves us with x minus 3 plus 3. And minus 3 plus 3 is x. There we have it. All right? So we can test it by composing f with g and get x. But that's not good enough. We've got to compose it the other way also. So let's switch it up and check out g of f of x. So we're going to put f into g. And let's see what we get. So we take our function g, this guy right here, and we have blank minus 3 divided by 2. So we take the input minus 3 divided by 2. That's all this means. Input minus 3 divided by 2. That's exactly what we need, all right? So let's figure out what that input is. That input is f of x. F of x is 2x minus 3. Actually, it's plus 3. All right? So now it's just a matter of simplifying. So let's do that. Up top, we see we have plus 3 minus 3. And so that's just going to be 2x all over 2. and these cancel, and that leaves us with x. So yes, these are inverses of each other. So we can say g of x is the inverse, f to the negative 1 of x. That negative 1 is not really a power, it's just a notation, all right? So f of negative 1, let's make that a little cleaner. F negative 1 of x, so the inverse of f. G is the inverse and vice versa. So what if we have 2x squared and the square root of x over 2? Let's compute that. So we have f, which is, so we got f of g of x. We want to put g into f, and it looks something like this. F is 2 times blank squared. That's what this function means. And what goes inside? Well, g does. So we're going to put g into there, and g is the square root of x over 2. Now we just clean this up. The squared is going to cancel out this square root here. And so we end up with 2 times x over 2. And those 2's cancel. That leaves you with x. And that's good. So when you put x in, compute g and then compute f, you just get x back out. Right? So they undo each other. So let's compose it the other way. Let's go g of f of x. So we'll start by writing down g, and we get the square root of blank divided by 2, because that's the square root of x over 2. That's what g says. So that's the form, and inside the parentheses we're going to put f. So we take f, the original function here, 2x squared, and let's put that in there. All right. And so the 2's cancel. Let's clean it up. 2 gone, 2 gone. And we end up with the square root of x squared. And the square root of x squared is x. So the moral of the story here is, here we can see it undoes it this way, and it undoes it the other way. So f and g are inverses or opposites of each other. They undo each other, all right? And one more of the same kind here. So we want to check. We're just verifying here. So we're going to take f of g of x, all right? So here's our g, and here's our f. So f says 4 times blank minus 8. And so the blank is what we're putting into the function, and in this case it's x over 4 plus 2. Now it's just time to clean it up. So we distribute the 4. 4 times x over 4 is x. 4 times 2 is 8. And we got the minus 8 that we started with here. And so this just equals x, obviously. All right. Now we got to check it the other way. Don't stop there. So g of f of x, got to compute that. So g is blank. Oh, back up. So blank over 4 plus 2. So that blank is just where we have an x. That's the input. So something over 4 plus 2. And that something is our input. So let's put that in there. And so we have 4x minus 8. Okay. And let's clean it up. So we could divide both of these by 4. So we got 4x over 4 minus 8 over 4 plus 2. These get canceled. And we end up with minus. It's a minus because it was minus at the beginning. Minus 2 plus 2. So this is x minus 2 plus 2, which is x. Okay. So we ended up with what we put into the function originally, which is x. All right. So these are inverses of each other. That's good to know. Lots of uses for that. And so we can say that the inverse of f is g. And that's how you test to see if two things are inverses. So now we can verify that two things are a function by composing them. But what if we want to find the inverse? In the last ones, we just said these are inverses. Well, now we want to figure out what the inverse is. So here's the steps. So an inverse just takes the x and y and flips them. Okay, it's making the input an output. Okay, so we're going to start by replacing f of x with y. Then we're going to interchange or switch the x and y, solve for the y, and if it's an inverse, we just write it as the inverse of f, and then we can test it out. All right, so let's do that. All right. So we have f of x. Well, first thing we're going to do is we're going to swap this out for y. Y equals x plus 1. 7, actually. Can't read. And so now we want to swap these two because an inverse switches x and y. And so we write it as x equals y plus 7. And now we want to solve for y by subtracting 7 from both sides. And we get x minus 7 equals y. All right? So there's our function right there. And that's pretty logical. What's the opposite of adding 7? Subtracting 7. Okay? So this is the inverse. And so we can say the inverse of f is x minus 7. Okay? And we can compose them to check this out. And let's see, what is f inverse of f of x, which is x plus 7. Okay, and so we just get x plus 7 minus 7, which is x. And then if we substitute this the other way, so we take f and we put f negative 1 in there, which is x minus 7. Then we end up with x minus 7 plus 7, and that just simplifies to x. So they are inverses, okay? So the inverse of f is x minus 7, right? How about 2x plus 6? A little more complicated here. Y equals 2x plus 6. Let's solve this, swap it out first. X equals 2y plus 6. And now we need to solve for y. So let's subtract this 6 there. X minus 6 equals 2y. And divide by 2. Don't try to divide that 6 by 2 there. 2 divides the whole side. Okay, so y, let's see. Yeah, that cancels. So the inverse is x minus 6 all over 2. Okay, and we can compose that to check it out. So to check it out, we have f of x. So f of, and let's plug in the x minus 6 over 2. Okay, well, our function f of x said this, 2x plus 6. So we have 2 times blank plus 6. And the blank there is x minus 6 over 2. And these do cancel. X minus 6 plus 6 gives us x. And that's good. That's what we're going for. Okay. Now, if we take our inverse function that we just found, this is our inverse function. This means subtract 6 and divide by 2. Okay. So there's our f negative 1. So let's start with that. F of, and let's put x in there. So the x is 2x plus 6. And so we get, here is f inverse x minus 6 over 2. So we have blank minus 6 over 2, 2x plus 6. Okay, and so when we're evaluating this, the 6 is going to go away. And we're left with 2x over 2, which is just x. So it checks out. It's x both ways when we compose it. So we found our inverse. All right, that's how we find the inverse. One more here. What about an x squared here? Now these guys all had inverses. If we got an x cubed in this case, is g of x. So let's go ahead and swap it out. We have y equals 8x cubed plus 1. We can now swap the x and the y. X equals 8y cubed plus 1. And let's solve for x. Okay, so we subtract 1. 8y cubed divided by 8. Okay, and we end up with y cubed equals x minus 1 all over 8. And last but not least, let's get rid of that by cube rooting. Remember that thing? So y is equal to, so y is the cube root of that fraction there, right? Cube root. Now we can actually cube root at the top and cube root at the bottom. So let's just cube root at the top because we can't do anything with it. All of the cube root of 8 is 2. Right? And there is our inverse of f. F negative 1 of x is the cube root of x minus 1 all over 2. A quick test should show us that these are functions. Actually, we're looking to see if they are inverse functions, not just random functions. And so f inverse of, oh, actually, this should just be a g, right? Okay, we switched to f, but we really should have g. Okay, so that's a g, and that's a g here. All right. So if we take the inverse of g of x, and that's going to be the cube root thing here. So the cube root of, just a second, the cube root of x minus 1 all over 2. And so if we put in 8x cubed plus 1 goes in there. All right. And we clean this up, we get, well, you can see plus 1 minus 1, those are going to go away. All right. And we have the cube root of 8x cubed, and that's just going to be 2x first, right? So this is 2x over 2, which is x. All right. And if we do it the other way there, it'll work out also. So that's how we use that and test that, all right? So last thing we want to look at is a quick test to find out if a function has an inverse, okay? For a function to be an inverse, it must be what we call one-to-one. A one-to-one function has different outputs for every input, okay? So every output is only used once, so it's perfectly matched. Well, if we look at our quadratic, negative 3 squared, so when we plug this in for x squared, we get 9, okay? We get negative 1. When you plug negative 1 in, 1 squared is you get 1. 0 squared is 0. 1 squared is 1. 3 squared is 9. Okay? Now, inverses flip the coordinates. So we get 9, negative 3. We get 7, 1. 0, 0. And flipping the 1 and 1, you can't see what anything happens. Flipping the 9 and 3, we get that, okay? Now, if we sketch a graph of this here, it's going to look kind of interesting. We have 9, 3 is going to be out here. We have 7, 1. Wait a minute, that's no 7 there. Oops, that's not it either. Okay, so it's supposed to be a 1. Okay, so we have 1, 1. We have 9, negative 3 somewhere over here. Actually, negative 3 down here, 9, negative 3. We also 9, positive 3 here. Okay, we got 1, 1, 1, negative 1, and 0, 0. Okay, so there's our curve there, and it's kind of a parabola on its side. So the question is that red thing there a function? Well, it turns out that it's not a function because it does not pass the vertical line test. If you remember that, okay? There's more than one point on a vertical line, okay? So it is not an inverse function, okay? This red one here is not a function because it doesn't pass the vertical line test, okay? Well, notice all that happened was this fell on its side, and we could have done horizontal lines, looked at horizontal lines to see if the function is 1-to-1, meaning it can't even possibly have an inverse, okay? Horizontal line test says this. It says that a function f has an inverse if there's no horizontal line that passes through it. We know if there's a vertical line, well, it's not a function. But if there's a horizontal line that passes, it's not 1-to-1, okay? So if we look here, can we draw a different horizontal line through all these points? I hope so. So we got some horizontal line here, okay? And so no matter where we are, we're going to only touch once. And so this is 1-to-1. 1-to-1. All right. This function here, okay, if we bring our vertical line over, it crosses a lot of places. So this is not 1-to-1. Okay. Not 1-to-1. All right. And this guy over here, we have lots of single intersections there, okay? And so it never hits twice. So this is a 1-to-1. And again, 1-to-1 means that an inverse exists. So these two have an inverse. This has an inverse. This one does not have an inverse. There is no inverse function because it is not 1-to-1. There's a horizontal line that goes through it. And the last thing we're going to look at is a quick look at some graphs here, all right? So first we're going to look at two functions that are our inverses, and let's see if we can find out what's going on. In other words, what a connection is between their graphs. So here's our two functions, 2x plus 3 and x minus 3 over 2. Get these two graphs. Now, you're not going to see too much going on there. So let's look at another one. Here we have next to 4x minus 8 and x over 4 plus 2. These are inverses. So they look like that, okay? And the last one here, if we take x cubed plus 5 and the cube root of x minus 5, we get these two shapes. Well, what's going on here? So if we look at all of these together, can you see a pattern? So they all the pairs, they meet. If we look at where all these pairs meet here, there, these guys meet there. These two lines meet back here. Oops, got that off a little bit. There they are, and there they are. All right, something's going on. There's a pattern there. All right, so if we look here, here they all are, and where they cross, there, there, and there. Those are all on this line. What is this line right here? Well, this is the line y equals x, all right? Because in an inverse, where we're taking the y and the x and we're switching them, okay? So the y stuff kind of flips over to the other side and the x stuff flips over. So they trade places. Y and x swap or move across the line y equals x. So that's the key, okay? So they are reflected across the line y equals x. So the key is it's reflect across or reflected across y equals x. All right. So that's useful to know. So if we have a graph and we want to find its inverse, the graph of its inverse. So here we have some funky looking graph. And we want to find its inverse. Well, we're going to take these points and we're going to reflect them across the line y equals x. When we reflect, we go perpendicular to the line and straight across, okay? And so here, this D, well, it looks like it's going to end up over here. So this is the new D, okay? We'll call this maybe, there you go, D prime. We use that for transformations quite a bit. So anyways, that's the idea. So it's going to reflect across there. Now what happened? D was 5, 2. Notice this is the coordinates 2, 5. Okay? The x and y just flip. That's what happens when we have an inverse. The x and y flip like we did back with those equations. So here this is at negative 2, positive 4. So we're going to go find 4, negative 2. Okay? And so we flopped them around, okay? Negative 2, 4. This guy is negative 4, 1. Well, let's flip that around and get 1, negative 4. There is our B prime. This guy was our C prime. Okay, so this is a 1, comma, negative 4. And last but not least, this one is at 6, 0. So we're going to swap that and hopefully not get too confused here. There's, whoops. Actually, let's go a little lower, right? Down here. A prime. All right, if we connect these, we can connect this, we get our inverse, okay? And so we can kind of see it's symmetrical here, okay? So this side looks just like this side, reflected across the line y equals x, and that's how we graph an inverse, okay? All right, well, there you have it. We can compose functions now. We can find the inverse of the functions. We can test them to see if they're inverses, and that will do it for us here. All right, so good luck finding compositions and inverses.